Hi there, my name is Dominic, and in this tutorial I'll teach you how to write maths and statistics equations in Latex. I will also teach you how to insert images like plots in your work. Let us first start by setting our work environment. For me, I prefer using Text Studio, and this is my Text Studio, but you can use any editor of your choice. So I'll start by opening my Text Studio. As I open my Text Studio, I will use the overleaf to quickly set up our working environment. As you can see, there is no project. So for me to create a new project, I click on here. To view the output, I click on Tools, View. As you can see, there is nothing displayed because there is no commands in place. So to set up this work environment, I will quickly go to the overleaf. Let me show you how you can set up the working environment using overleaf. So you come here to New Project, say Blank Project. Let me call it tutorial. Create. Let's wait. So I'll come here. I'll just copy paste this to my text studio. I'll run this. Wow, our work environment is now ready. You can see these are the codes and this is the output. Let me change this other name to Dominic. Oh, now everything is in place. I will first start by showing you how you can write things in math mode. For example, letters in math mode. So let me change this section to math mode. To write things in math mode, we use the dollar sign. So for example, let me show you the difference. See the difference between x and x. I want you to notice the difference between the two x's. This is our output. As you can see, the first x is in math mode. It's significantly different from the second one, which is the normal x. Let us try using letter K. We want to see the difference. To make this sentence come to the second line, you can just use the double backslash like that. Now you can see there's a difference. There's a clear difference between the first K and the second K. The first K is in math mode, while the other one is the usual K. So that's basically how you write letters in math mode. You first open with a dollar sign and remember to close with a double sign. With a double dollar sign, sorry. Now, let me show you how to write letters with superscript or subscript. So I can call that a subsection. Subsection, superscript, and subscript. Let me start with subscript. So for you to write in subscript, say you want to write x underscore 1. Remember to use the dollar sign, open and close the dollar sign, write your x underscore 1. Let's view this. You can see how it is written. That's how you can write a subscript. Let us say you want to write x underscore 2n. If you're using two letters, you have to use the curly brackets. So for example, x underscore, open the curly bracket because you're using more than one letter. Let's say x underscore 2n. Let's see what happens. Here it is. That's how you can write in a subscript. Either you have a single letter or more than two letters. For two letters or more than two letters, remember to use the curly brackets. Let me now show you how maybe you can write a superscript. Script is something like x squared, x cubed. Superscript. Remember to open and always close your dollar sign. Say for example, we want to write x squared. Just write that x raised to power 2. It's that simple. Wow, you can see. Say for example, you want to write now x raised to 2n. Remember to open and close with a dollar sign. X raised to power, open the curly bracket because we are using more than one letter, 2n. Run that. Wow, you can see. So let us assume we didn't use the curly brackets. Let us see what would have happened. I'm using the double backslash to go to the next line so that they don't appear in the same line. So assuming there was no curly brackets, what would have happened? So you see what Latex would have interpreted that to be x squared n. So for us to achieve what we want, x raised to power 2n, we have to use the curly brackets. If you don't use the curly brackets, this is what you get. Okay, now let me show you how you can show finite. Showing finite. That is infinity. Things like 1, 2, 3, all the way to infinity. Remember to use the dollar open, close the dollar sign. So you can write x underscore 1, comma, x underscore 2, comma. Now, this is how you show finite. Backslash dots. Sorry, in small letters, dots. So that's how you run an equation for showing finite. Let's see what happens. That's how you can show finite using the dots function. You can also use, let us see the difference when you use dots and three dots. This is what happens. You can see the difference. This is the difference. You can use any of your choice, but for me, I prefer the first one, dots. Now, let us move to another subsection. I want to show you how you can do fractions, how you can write fractions. Let me call it subsection fractions. Writing fractions is quite easy. What you do, you just use the backslash frac. That's what you use. No, not double. You use one frac. But as you can see, this part is painted with a different color. That shows you that you're more likely to run into an error. You can see math command outside the math environment. So to set up it into a math environment, you can either use the dollar sign as that. You see it has changed. You can either use the dollar sign or you can use this to show that you're actually trying to write an equation. You can use that sign, these ones, to show that you're actually trying to write an equation. These two must be there. You open and you close. So for example, we want to write for a fraction, say 12 over 13. Simple. Backslash frac open, that is the numerator, and that will be for the denominator. So here you write 12, here write 13. These spaces don't matter. You can see some error somewhere. I don't know what's happening. Maybe I'm running, but maybe I'm running into a serious problem. What could be the problem? Let me try again. Oh, the spaces were bringing error, so I guess the spaces do matter, because you can see I'm getting warnings. So for you to use this type of format to show that you're actually writing an equation, you have to make sure there's no spaces, as you can see. So while I'm good, here's our fraction. Okay, you can let us try another one. Let us try writing. Let's try writing a more complicated one. Let's say 1 minus 2. Say 1 minus 3. See what happens. Wow, here we are. We are good to go. So now you can write fractions. Now let us move to letters. How can you represent less than, greater than, less than or equals? It's quite simple. We do the same. Let us now have a subsection of, let me just, allow me just to write less than, greater. You know what I mean when I just write that. I'm just trying to create a subtopic. So for example, you want to say that 2 is greater than 1. Remember to use the dollar sign and close the dollar sign. So you are trying to say 2 is greater than 1. That is simple. You just use the notations on your keyboard. Here we are. 2 is greater than 1. So you want to show that y is less than. Now let's try something else, something more statistics. Now let us try saying y is less than xi. That's a good one. X underscore I. So remember to use the double sign, double dollar sign. We have said y is less than xi. Just write x underscore I. Easy. And here we are. So those are the different ways in which you can now make sure. Now you see the importance of using the superscript. We are now using it in less than or greater than. You can also use it in the fractions. We will write more complicated equations as we move by. I just want to make sure that you are comfortable on writing fractions, how to use the superscript, how to use the less than or greater than sign. Now let us, perhaps you want to say that m is less than or equals to n. The approach is different, but quite easy. What you do, you can say, remember to use the open and closing dollar sign. You can say m backslash le less than or equals to n. There we have, see. So for example, we want to say greater than or equals, just the same, change L to G, greater than or equals. Here we go. So now you can represent things in using the greater sign, less than sign, less than or equal sign. Now, oftenly, you will encounter integration and differentiation in your project. So I want to tackle another subsection. Let me copy paste this here. Let us now check on integration and differentiation. You can see how beautiful these presentations in Latex are. These are some of the amazing things that Latex can do. Oh, sorry. Okay. Now, for you to write the integration sign, you can use this symbol that I was talking about. We have seen that these symbols bring error in cases where we have spaces, so we try not to have spaces in our equation. So for you to write the integration sign, you just use the backslash int. Sorry, small letters, int. That is the command. And the good thing with Studio, why Happify it is that it allows you can see that syntax from here. You can choose, for example, I can write int here, int of f of x, let me say dx. Let's see what happens. Wow, see how simple it is. And now say, for example, we want to define so that we have limits in our integration. You just write here, we can copy this, let us copy paste here. At your int, immediately after your int, let me call it function or command, just write an underscore, open curly bracket, that is the lower limit, another curly bracket for the upper limit. You can say A and B. A will be our lower limit, B will be our upper limit. Let us see what happens. Oh sorry, I wrote the B, I wrote the B outside the curly brackets. I guess what is not happening? Sorry, you have to write you have to write the A raised to power, the other one. That's it. Okay, what I'm trying to mean is that if you want to use the integration sign, that is int, you can choose it from here. That's the good thing with Studio, you can choose it from there. So see, you can write A, and here maximum you can write B. Let's see what happens. Here it is. You can add you can use double dollar signs instead of this representation here to mean that it is an equation. Let us see. Here it is. See now. So you have to write A raised to the power B. That's what happens in integration. Now let us quickly move to differentiation. You know what I mean when I write that. So let us quickly move to differentiation. I will use now, we're going to look at partial differentiation. So for example, let me copy paste this. But what will be inside these braces will be different. These square brackets will be different. So for example, we want to look at a partial derivative. So now instead of the integration, we use the partial derivative. Let us try and make it more complicated. Let us make use of the fraction, the command fraction, so that we can have derivative of d over dx. So the fraction, and you know what fraction means. You can see a numerator and denominator. That's the good thing with Text Studio. You can easily choose what you want. Now I want to write the partial derivative, and the sign for partial derivative is just partial, and the other one is, we want to write d over dx. So the other one is partial. The first one, I want you to understand, the first is d, the other one is dx, so we have to write an x. Let's see what happens. So here we have our partial derivative. It's that easy how you can write. And now you see, now we are incorporating the fraction sign and the partial derivative sign. So the fraction side tells us you have to give us the numerator and you have to give us the denominator. So, and this upper sign, this d here on the numerator is the partial. This other small d here is this. And for us to separate this dx so that there's a space between them, you can just easily write backslash, that is it a colon? I think it's a colon, yeah. And you can see it is spaced. So now that's how you can use the integration and differentiation. I'm trying to bring you up to speed so that you can write complex equation, which we will do by the end of this topic. Now, let me now teach you on elementary functions. So I can create another subsection here. Let me create a subsection. You can also choose from here. Elementary functions. And by elementary functions, I mean like something like sine, tan, cos, log. So I want to show you how that can be achieved. You just have to enter into the math mode. Always remember to enter into the math mode using the dollar sign and close with the dollar sign. So for example, sine, sorry, small letters, sine x. You can also do something like cos x. You can also do something like tan x. Let's run this and see what happens. These are the elementary functions that I'm talking about, and here we have them. You can see the x. It is quite different from, let us write here and x. And x. That's the difference. What does dollar signs do? Notice the difference between the small x and the small usual x. So the dollar signs gives us the first one. Without dollar sign, we get the second one. So those are the elementary function. You just use the backslash. If it's tan that you want to use, you write tan and then x. That's some of the things you write. And now maybe if I can show you the different ways of spacing this. Let me come here and copy this. I want to show you on how you can maybe space. As you can see here, they are not spaced. I want to show you different ways of spacing. Of course, you are familiar with the first one that I've taught you on how to space d and dx. So you can, your gaze is good. Your gaze is right. That one will space that for us. Can you see the difference? Can you notice the difference? So backslash colon can also be used in spacing. You can space this each twice. The more you input it, the more it spaces. The more you input it, the more space you get. Notice. Now, you can also use another one called backslash quad. Backslash quad. Let us use it between cos and tan and see what happens. As you can see, there's no spacing here yet. So let us now use it between cos and tan and see what happens. Wow. See? Quad. You can also write a quad with Q. Now to double Q. Let us see what it does. Notice what has happened. Bigger space. Those are some of the ways in which you can use to space in your equations. Now let us move to Greek alphabets. These Greek alphabets are things like, say, alpha, beta, sigma. I'm trying to bring the basics so that we will be able to write complex equations. Now, let us now check something on Greek letters. As you've seen up to this far, that it is just easy. Just remember to use the dollar sign and close with the dollar sign, and everything flows. So now let us check on the Greek letters. For example, we want to write alpha, beta, or gamma. So what do you do? Enter math mode, open and close. Now let us say you want to write gamma. Say we want to write beta. Say for example you want to see mu. It's common because the sign is common. I guess row is also common sometimes. Row. Let us run these ones. So this is what we have. These are some of the Greek letters: alpha, beta, mu, and rho. For example, there's also, we have a capital gamma, the bigger gamma, if I can call it that way. Let's see what the difference between the first gamma and the second one. Notice the difference, the first gamma and the second one. These are some of the things that you will encounter. So you can try and space them using what I have taught you. You can use a backslash colon, backslash colon. Let us just try those for now. See, spaced and the others are not spaced. Now let us try that between rho and gamma. Let us write quad. Let us see what happens. See, space. So those are some of how you can play with those functions. How to space the Greek letters to use in your equations. Yeah, those are some of the ways you can do that. Now, perhaps can we try beta raised to power x? Let us try and see if we can get something from that. I'm not quite sure of that. So you write beta, is it beta? Yeah, beta raised to power, let's say x. Let us see if we will get something. Let me use this one so that sorry. See? Now that's how you can play with these Greek letters, how you can write superscripts, how you can write what is it called? Subscript. Now let us try and write a subscript. You just have to write beta underscore x. Now I think you can see the importance of why I was introducing the superscript, the upper script, now the Greek letters. This is what now you get. See, beta underscore x. So those are some of the things you can do using after learning this superscript, subscript, how you can get the fractions. Let us now try writing the fraction of beta over mu. Let us try something like beta over mu. We are just playing here with functions. We are not doing anything. So let us try write a fraction, right? And the command of fraction, we saw it was frac. The good thing with text to date gives you what you want to write. I wanted to write beta as my numerator, and I want to write is it mu as my denominator. Let's see what we get. See how you can make use of the fraction, the superscript, underscripts to write such things, and the Greek letters. It is that easy. So how to enter into math mode? Remember always to open and close with the dollar sign. So now maybe I can introduce you on how now you can write an equation, how you can write, label and reference equations. So maybe I can come here, subsection, get another subsection now. Yeah. And now you can write an equation, how you can label it, how to label an equation. Now you can reference an equation. Wow. So in this section, we are going to introduce a new command. No, that is now we are trying to label an equation different from, instead of using these ones, let me copy it. Now, instead of using this, I can use begin equation in place of that. Begin equation, and as you can see, I already have them here. Immediately you click that, it tells you, text studio tells you where your content should be placed. So this was my equation. and I will place it here. I think I've done it quite fast, but I will repeat the process again for you, so don't worry. Can you see what has happened, the difference? Let me remove this finite here. Can you see the difference between the first one and the second one? Notice the difference between this one. Oh, sorry. This one has been labeled. Notice the difference between that. What was the other one? Notice the difference. This one is not labeled, while this one is labeled. So if you use begin equation, you are telling Latex that this is an equation and label it for me. If you don't want this number to appear here, you can just add asterisk here, like that. Make sure it is in begin equation and end equation. Run that. Sorry, I don't know what has happened. I'm not quite sure what has happened. Anyway, let us now write an equation. Let us write an equation from scratch and see what happens. I want to show you, we can begin an equation here. Begin equation. Begin equation. We have now begun an equation. So what can we write here? Let us try the fraction. But fraction, you have to have the numerator and the denominator. So in our numerator, let us have d or dx. Yeah. Or we can have beta. In our denominator, let us have what? Let us have mu x, right? Let us have mu x or mu times x. Let us have mu times x. Let us see what happens. I'm not quite sure of. Okay, here's what we are getting: beta over mu times x, and this is what we have. So you can label this equation. Before I label this equation, let me try something. Before we label that equation, let me try something. Whatever I'm seeking to try is not happening. Anyway, let me see. Or perhaps these spaces could be bringing the errors. Never know. Maybe it wants me to start from. No, I don't think so. I don't think so. So for begin equation, sorry for those errors. I was trying to show you how now you can create, how you can use begin equation to write this way, and now how to label this equation. For you to label an equation, you just have to write backslash label. How can we call it? Let us call it equation 1. Just call it equation 1. You can write anything in here. You can also write your name. You can call it label. You can label that equation to be your name, say Dominic. So that's how we've labeled. That's how you label an equation. Now perhaps you want to reference the equation that you've labeled. What do? You can say solving. So you are saying solving equation. You want to say solving for equation 1. This is how you reference an equation. You backslash reference, open the curly brackets. How do we name our equation? Equation 1. Solving equation 1 becomes, that's how you label an equation. Okay, see, solving equation 1 becomes, this is how you reference an equation, so that now when someone is reading through your document, he can click here and will be taken to where that equation is. So you first have to create the equation, label the equation, reference the equation. We are good to go. Now I want to show you how to list items. Now let me create a section called listing items. Section. Good thing with the text studio, you just pick from there. You want to do what? I want to show you how to list items. Say items 1, 2, 3, 4. And the way to do this is just use this command: begin enumerate and end enumerate. Begin enumerate, and end enumerate. And as you can see, it's already here. So what do you want to, you can list. Now to list the items, just use /item. Say you want to list car, /item, you want to list house, /item, you want to list food. See, that's a good way of listing items. It's a good way of listing items. 1, 2, 3. You can also try, for example, say you don't want this 1, 2, 3, 4. What you want a different way to do this. You can call a command called itemize. Begin itemize. Different. Let us see the difference. Begin and end itemize. Remember, anywhere you decide to use this begin, you have to begin and you have to end it. So that's one way of listing these things. Wow, you can see the difference. Yeah, this is for itemize and this is for enumerate. We are now good to go. Before, I didn't want to tackle this fast, but I had forgotten something. I wanted to show you the sum notation, which is common, and the product notation. Someone might be wondering why I'm using the percent sign here. Anything you use the percent sign here is used as a comment, and so it will not appear here. So whatever I wanted to do was to create a subsection. I wanted to create a subsection of sum notation, and product notation. So I want to show you how to use these things so that you can be able to write complex equations, which you will enjoy doing. So we are now in this section. I want to show you how to use the sum notation. So we can maybe try begin equation. Begin equation, begin equation. Sorry. Begin equation. And the sum notation, to use the sum notation, just use a /sum underscore. The good thing with this text studio, and I'm keeping repeating myself, is that it allows you to, it predicts what you're trying to do. So it's telling me for sum, this is the syntax. So write the minimum. So I want to say maybe from I is equals to 1, I is equals to 1, count all the way to n. Remember, if you begin, you have to end. Equation. Here we are. But I guess these spaces sometimes tend to I don't know if it's the spaces quite really, but let's see. Yeah, sure. You don't want to have spaces in your when you are writing an equation, otherwise you will have a lot of errors. So make sure you don't have spaces. So you can see this is the sum notation. So for example, you wanted sum of I is equals to 1 all the way to n. That is the syntax, as I've shown you. You can write maybe 1 plus 2. Let's see, 1 plus 2, 1 plus 2, 1 plus 2. So here she is. So now let us we check on the product notation. I'll just copy paste this, begin equation and end equation. For that, let me try something. I've been trying here something that is not working. Up to now, it has not working. I don't know why. Okay, I will tell you why it is not working. It has actually, that is, if you want to avoid numbering your, if you want to avoid numbering, let us run without the asterisk here. If you run without the asterisk, this begin equation will be numbered. This is equation 1 and this is equation 1 and equation 2 is here. If you don't want this numbering, you just put an asterisk here. Try running that. I want you to see something here. That the number has disappeared. There's no number here. But the reason I'm getting these errors, let me try. I guess we are missing a package in our. There's a package that we don't have here. Used to write equations in a beautiful way. And the equation could be I'm smart. I'm not sure. I'm just trying. I'm smart. Let's see if these errors will go away if we use that package. Wow. So what was that which was really happening was that we did not have this package. This package is very important. Use package armsmath is used to write equation, and that's why every time we used to add an asterisk to begin equation, we were getting errors because of that. As now you can see, our equation hasn't been labeled. This is just the page number, but our equation has not been labeled. Maybe we can try here. So to go to the source of this code, you just have to right click here and then click here, go to source. It takes you here. So for example, we don't want to label this equation. We don't want this one here. What do? Put an asterisk sign there and also put an asterisk sign there. What happens? Nothing has been labeled. It has disappeared. So that's one way you can write an equation using the syntax of the begin equation, and if you don't want it to be labeled. If you want it to be labeled, don't put the asterisk sign there. And so we are back again. So that is what we were trying to see. So the package, we have seen that this package is very useful when we are writing our equation. Always make sure it is there in your document. You can always add it. Use package armsmath. Okay, now we have already tackled the summation notation. Can we try something interesting before we go to something else, how to write items in boldface? We can make use of the sum notation, we can make use of the fraction, we can make use of the subscript. Can we try those all in one? Let us write an equation with all those. Copy, Ctrl V. So for example, we want to write the summation of I is equal to 1 up to n, and we want to write a fraction. Frac, let us say we want to write, what do I 2 underscore n, no, x underscore n, x underscore n. What have I done? Sorry. We want to write now, we want to include a fraction here. Fraction, numerator, denominator. So we can write x underscore I. Let us now try here a superscript, x raised power 2. Wow, we have made use of a superscript and a subscript and a fraction. So in our equation we have the sum notation, we have a superscript, and we have a subscript. So that was the importance of introducing you to fraction, superscript, and a script, and maybe even a Greek letter. We can say instead of x underscore I, we can use a Greek letter, say beta underscore I. Let's run that and see what happens. That's how you can play with these notations to get things like this. Now you see, we have beta underscore I over x squared. We have made use of the Greek letters, we have made use of the superscript, we have made use of the fraction, we have made use of the superscript and the subscript. So that is one way to do that. Another, also I hadn't shown you how to write the product notation. For the product notation, you just change the sum to prod, like that, and you get sign. Here it is, the product notation, the sum notation, product notation, sum notation. So now me show you how now you can write things on boldface. So for example, you want to write a letter, say x in boldface. You can say or you want to write, let's say I want to write my name in boldface, Dominic. I can say let, this is the command for writing in boldface, bf, text bf. Yeah, that's a good thing with text to write what you want to be written in boldface. Let Dominic. See, it has been written in boldface. So this is the command to write in boldface, that is text \text bf. That's a good way of writing things in bf. I wanted to show how you can include graphics and figures, but before I introduce that, let me check on a section. Let us now look at matrices, how you can write matrices using Latex. So allow me to create a section called let me create a section called what? Let me create a section called matrices. Matrices. I want to show you how you can write a matrix. Oh, to write a matrix is quite easy. Write a matrix is quite easy. You just use begin and end. That's it. Begin and end. Anything you begin, you have to end. So what are we beginning? We are beginning a matrix. So say begin, and you can see here you have different types of matrix. You have the B matrix, you have the V matrix. So Latex will bring you options. You are not quite sure of what you want, but we want to write a P matrix. Begin P matrix. that whatever you begin, make sure you end. So we want a begin matrix. So for example, we want a 3 by 3 matrix. So you can say maybe the entries are 1. Replace one from the other, you use the AND function. And maybe the other one is -1. You want to create a 3 by 3. You use AND to separate it from the other. The other one maybe is 0. Remember to use the backslash, double backslash to go to the next line. So maybe the other entry is 2 and 7 and 7. Remember to use the backslash to go to the next line. Maybe the other one is 0 and to separate it from the other 3 and 10. So remember, whatever you start, you have to end. And P matrix, P matrix. So I don't know. I guess these spaces can bring problems. So let me make sure there is no spaces. So as you can see, we have our matrix here, of which the entries are there, but I have errors. And because it's a math mode, yeah, I have to introduce you either use a dollar sign or you use begin equation. So you can use this dollar sign. I don't know if it will help. We can use that, and you can see now everything is okay. This is used to tell if you don't put the dollar sign, it will bring errors, because as it is well known that 1 is indeed mathematics, 3, 10. Those are numeric, so you have to use this dollar sign. Otherwise, it will bring errors. If you want to center it somewhere here, then you can add another dollar sign. So you have a dollar sign, and here you also have a dollar sign. That is if you want to center it. Yeah. You can also say, instead of using double, you can also say begin equation. Because this is indeed an equation, you can also say begin equation. There are many options. And remember, whatever you begin, you have to end. Whatever you begin, you have to end. See, it has been numbered. If you don't want to label it, to number it, use the asterisk there. What has happened? It has disappeared. For example, you want to reference this matrix, so you will label this equation. I hope you did not forget how to label equation. So we can call it maybe equation. You can say D. You can call it equation D. It doesn't matter what you put in here. So we have labeled that equation D. We've labeled our equation 2 as D. So for example, we want to reference it. Solve matrix what? Ref, what they call it? Call it equation D. So that's how you reference an equation, how you label an equation. So here it is, so that anyone reading your work can easily click this number and will be taken to that equation too. So that's how you label an equation, of which we have seen. This is how you create a matrix, and this is how you reference an equation. So anyway, I don't want to label this one. So for example, now we don't want to have it in curly brackets. We want square brackets. What do? Let me copy this. In the event we don't want these brackets, we want the square brackets. You just change P to B matrix, P to B. That's what you do. And here it is, you see. So you just, if you want the one with brackets, use P. The one with the square brackets, you use B. So before I show you how to insert graphics, I want to show you how you can align equation. You know, in mathematics, you will often come across simultaneous equations, and so you have to align such equations. So allow me to create a subsection. Allow me to create a subsection called align equation. You can already guess the syntax that I'm going to use. The other one was showing you how to create an equation. It is begin equation. And now I'm showing you how to align an equation. So it is begin, align, and align. So and Latex is quite easy, and you will find it interesting writing your equations using Latex. So now let us begin. How to write? I have say I have the equations and I want to align them. So this is the syntax there. Begin, align, and Latex will always tell you. See, Text will always tell you what do you want. Do you want to align this? Do you want to align with an asterisk? If you align with an asterisk, there will be no labels. So if you align with that, there will be labels. So you want to align those equations. So write your content here. For example, I want us to make use of the superscript and the fraction. So let us make use of the superscript. Say x raised to power. Let us now not use one letter. Let us use two letters. Remember we said if you're using two letters, remember to use the curly brackets. 2 raised power n plus, can you use a fraction? Now let us use a fraction in the next equation here. So we can just write 4x is equal to 3 negative 1. Now let us make use of can you make use of a Greek letter? Let's make use of a Greek letter. So beta, and let's make use of a, and let us make use of script. Say I. These equations are not true, but I'm trying to incorporate what we've learned so far to make some complex type of equation. So beta bi plus, we can say, let us now use here a fraction. We can write x over 2 times x. 2, instead, for multiplication, you just use that command times x. So is equals, say 0. So let us write another equation, maybe x is equals to 9. Let us see how this equation can be aligned. Oh, sorry. Remember to always use you see what has happened? Our equations have been written in one sentence. To avoid this, remember to use a double backslash in every sentence. You can also use it here, but it's not necessary because there's no equation following it. But you can also use it. You can use it. Doesn't matter whether you put it or you leave it. So you can see how equations have been aligned. And you can see they have been labeled as equation 4, 5, 6, and 7. So to avoid this kind of labeling, you can just input an asterisk there, another asterisk over there. This is an important feature of aligning equations, a very important feature. You can see what we have. Look at x raised to power 2n. If you're using more than one letter, use the braces. We have made use of the fraction, the Greek letter, the superscript, and the fraction. So those are some of the amazing things you can do. Last but not least, and I love actually, I love this because I do statistics, and in statistics you encounter a lot of graphs that you have to present in your work. So I'm going to show you how to include such things. In this section, I'm going to call something called as graphics and features. Graphics, not features, sorry, and figures. There we go. So before anything else, we don't have graphic. We don't have a picture that we want to upload. So we have to create a folder whereby we will put that image. So let us create now a folder here, new folder. Let me call this folder tutorial. Okay. Let us go back to our Latex. I want to save this work that we've been doing so far. It is really important so that I can show you how we are going to create this section called graphics and figures. Here, this section called graphics and figures. So I'll come in here, file, and I'll say save as. I'll quickly go to desktop and go to what I've just created now tutorial. I'll save that work there. Save. I've saved our work now there. So in this folder, as you can see, these are whatever you do comes here. So for example, as you can see now, we only have one document. So let me show you what happens. If I run this, I build up and run this, anything you do here automatically saves in that folder, in this folder. So you have your PDF file here. Let us first open this PDF file so you can see all that we have been doing. Here it is, all that we have been doing. Here it is. So we are here now in graphics and figures. So everything you do automatically saves where? In this tutorial. And so this is our the studio, our run command. So for us to upload, if you have a graph somewhere or a picture somewhere that you want to upload in your document, you have to bring it in this folder. And I had prepared this picture here so that to use it as an example of how we can upload such a figure into our work, this one. So this is what we are going to upload, and as you have seen currently it's not in our folder. So what I'll do, I'll just copy or rather cut it and I will paste it here. It is now here. Maybe I can rename it. Let me rename it. Can I rename it to my name? No. What? Yeah. Let me rename it to my short form name. Call it Domi. I've called that figure Domi. So back to our Latex. So here we use the command called as include graphics. So the small letters. Include graphics. And you might have seen that Latex doesn't recognize anything like this command. I don't know why. I know why. I know why, but I want you to notice that I have not been brought options, and I'll tell you why in a few. So include graphics. Say I've called the graphic domain. Let us see if it will indeed be uploaded. It has not been uploaded. Instead, a name has been written on it, and I'll tell you the reason why. The reason as to why this has not been uploaded, there's a package used to upload such graphs and figures that we have not suggested for use in our work environment. So you quickly go to the top, and what you do is that power failing me. So what we do, you quickly come here to the use package, copy that. We add now the package that supports graphics, and the package goes just by its name, graphics. Instead of S, I'll use X. Sorry, graphics. So this is a package used to upload such figures. So if you are uploading a graph or a figure in your work, make sure you have that package. So let's see if that works. What, I don't know. Yeah, this it has been uploaded. Say for example you want to reduce its size. So what do? You can use this square bracket and use the command scale is equals say maybe 0.5, half of it. So this is the way you want to reduce the size of this one. Wow, you see. So the command here used to upload is called use package graphics. The function, or rather the command that we use to upload, is include graphics scales 048. Now let us customize this further. Now you can well represent it in your work. I want to customize this for you. This is not important. It is just maybe I'm trying to play around with how to use the boldface, but it's not necessary. Actually, let me comment it, because I want to show you how to customize a good representation of a figure. So what you do, you say begin. You are beginning something called a figure. You begin, that is the command. You can always just copy the command directly. Is begin figure. You want to center the figure in your work. You want that particular picture that you have or graph, you want it to be centered in your work. So you may write this one, centering. You are now centering it. Now you want to call that that particular graph or figure, whatever it is in your work. So you use this function that we've used before. As you can see now, the package is installed, and now we are getting suggestions. So it is include graphics, and I named it to me. I named it the short form of my name. From that, maybe want to add a caption under your figure. You just use that command caption. What do you want it to be written? Maybe illustration of censoring scheme. Maybe that picture is an illustration of a censoring scheme. Or maybe it's a graph. You want to talk about the birth rate of a certain country. So you can just write here birth rate of maybe Zambia, United Kingdom, maybe India, maybe France, maybe Tanzania, maybe Rwanda, maybe South Africa. So this is the caption that you want it to be labeled there. You can also label a figure so that maybe you'll be referencing, say, clearly from figure 2 can be seen. So you can also label it. Now we are customizing our figure, how we want it to be well represented. You can label it. You can call it your name. You can call it figure 1. You can call it, let me call it fig 1. You can call it anything. And now, whatever you began, you end. Wow, now let's see what has happened. Here it is. You can see it has been uploaded. Our caption is here, illustration of censoring scheme. Here it is, illustration of censoring scheme. So this is what we call the caption. And so this is the figure that has been uploaded. So for example, you want to reduce on its size. You can always use the brackets, the scale function equals maybe 0.8. Let me say 0.75. Let's see. If I want to reduce the size of it, I'm getting error. This it couldn't read 0.75. Maybe can I try? No, it could read. It's me who wrote the scale in the wrong way. So it's scale. Maybe scale 0.75. As you can see, it has been reduced. So that's how you can play with these brackets and scale function to either increase or reduce the size of your pictorial. So we have now customized our picture. You can upload a picture to your work. And how can you now call it? How can you reference it? So you can say from figure, you just use the same reference that you used in equation. Say for figure, say reference. This is what we used to reference. How did you label it? We labeled it at figure 1. There's a run from figure. So anyone reading your work can easily click this number 1 here. I like customizing it with brackets. Anyone reading your work, sorry. So anyone reading your work can easily click on this and will be taken to where that picture is. So that's how you reference an equation, a graph. That's how you upload a graph in your work. That's how you add a caption. That's how you can customize your graphics. I think I have tackled enough. Thank you very much for watching, and please don't forget to hit the subscribe button below the video if you haven't done so already. Finally, please hit the like button because that tells me you find this tutorial useful and also motivates me to create more content for you. All the best in your learning experience. Thank you very much.